Welcome back to the Tech Couch, and in this video I'm going to do a side-by-side comparison of the evolution of temperature in a plastic water bottle versus the S'well water bottle. This video is an addendum of my previous video where I did an overview of the S'well, talked about it, and showed a comparison, showed how well it kept its heat over a 12-hour period and how well it kept its cool over a 24-hour period, plus did a very basic side-by-side comparison. But in this video, I prepared some really cold water. I'm going to put it in both, and I'm going to measure the temperature periodically over the short term to see how it differs between a plastic water bottle and the S'well. So first, we're going to fill these up, filling them both up to the full line. They're both 500 mLs. So it's looking like it's about 4.8 degrees, 5 degrees. So just around 5 degrees in the water bottle, and 4.9, a little bit less in the S'well, 4.6. So, and this temperature is changing pretty rapidly at this point because it's at its maximum coldness. So it's going to exchange heat with the external environment at its maximal rate. But we're going to start off by closing these up, starting our timer, and we're going to check back in a few minutes. Okay, so here we are just past the 5-minute mark, and I'm going to measure the temperature of each of these. We'll start with the water bottle on this one. Somewhere around 6, 5.9, 6.1. Close that back up. And then we'll do the S'well. And the S'well is definitely a little bit lower, somewhere around 4.6, maybe 4.8. So those are the readings we're getting. So we will close that up, and we'll check back in a few more minutes. So at around the 11.5-minute mark, we're going to measure it again. This time we'll start with the S'well. So looks like we're still around 4.7, 4.8. And we will go to the water bottle, which is around 7.2, 7.3, maybe 7.4. But we'll close that back up and we will check back in a few. Okay, so approaching the 20-minute mark, we're going to measure these out again, see where we're at. Talking about maybe 8.3, 8.2. And the S'well, looks like we're still under 5, maybe 4.8, 4.9, maybe 5.0. We'll check in again. Okay, so now we're at the almost 28-minute mark, and we are going to measure these out again. So let's start with the S'well this time. Still reading below 5 degrees, or maybe right at 5 degrees. And the water bottle, which is now in the high 9s, 9.9, 10, 10.2, 10.3, something around there. Okay, so now we're at the 37-minute mark. I'm going to do the same thing again. And give these each a quick little shake before, just to mix them up. Here's the S'well. Still reading in the low 5s, even in the high 4s maybe. And we'll try the water bottle. And we're getting in the high 10s. There's a 10.9, 11.1, 11.2, so 11.3. So we're talking high 10s, low 11s. now approaching the 48-minute mark, 50-minute mark. So we're still in the low fives, looks like around 5.2 for this measurement. And we will do the water bottle. And the water bottle is in the high 11s, 11.9, maybe 12.0. And we'll check back in for one more checkup at the 1 hour mark. Okay, so we've just crossed the 1 hour mark. I'm gonna do my final measurement. And we'll start with the swell. It has been doing quite swell so far, so let's just see how we close out the hour. And it's still in the low, maybe mid fives. We're reading 5.3, 5.4. So that was pretty successful. It's hardly gone up at all in that hour in temperature. Whereas the water bottle has gone up to above 12. We're at 12.4, 12.6. So maybe the high 12s, low 13s it looks like. Basically around 13 degrees. So you see the big difference. The swell hardly changed in temperature, whereas the plastic water bottle has gone up significantly. So for the final part of this video, I'm actually just going to compare the volume of the swell to a water bottle. As I was doing these experiments, I was quite impressed with how well the swell held up relatively. And looking at the design, I was kind of thinking, you know, it's actually such a sleek, compact design for something with so much insulation that I wanted to see how much more volume this swell had compared to a regular water bottle. So to do that, I've created this setup here. I have this jug that's completely filled with water up to the top. I'm going to submerge the swell, measure how much water it displaced, and then do the same thing for the water bottle. So I'm just going to start by doing the swell like this. Keep slowly letting that spill in. So the entire volume of the swell is 800 milliliters. To fit 500 mLs of water, not too bad. And we will test the other bottle out as well. We would expect it to be, you know, around 500 mLs, but we will see what it measures out to. Okay, and we'll do the same thing for the water bottle. Sure enough, we're looking at about 550 milliliters. Cool. So there you have it. You got a swell versus a water bottle. The swell really held its temperature. It's got a nice sleek design, it looks nice, and it's only 300 mLs more, or about 60% more volume, which isn't that much when you're getting that ability to keep your water so cold or hot. So if you haven't seen our first video where we overviewed it and compared, did a heat test and a cool test, definitely check that out. Otherwise, thank you for joining us, and we look forward to seeing you in the next one. Take it easy.